This video will mainly be an overview of sugar substitutes. However, before we can talk about sugar substitutes, we must first gain an understanding of regular old table sugar, aka sucrose. Sucrose, otherwise known as table sugar, which commonly comes in white packets, is derived from either the sugarcane or sugar beet plant. Sugar causes tooth decay, weight gain, and type 2 diabetes because sucrose spikes blood insulin levels, which can lead to both weight gain and the development of insulin resistance. The chemical formula of sucrose is C12H22O11. Sucrose has approximately 4 calories per gram. It is a carbohydrate made up of a glucose molecule and a fructose molecule. Sucrose can be synthesized in a dehydration reaction between glucose and fructose. As one would expect, sucrose has a very basic and traditional sweet taste that most people are very familiar with. With sucrose, there is little aftertaste to speak of. Because most sugar substitutes are many times sweeter than regular sugar by volume, they are often cut with dextrose to make the volume in a packet similar to that of a sugar packet. Dextrose and glucose are two names for the same chemical of the formula C6H12O6. Also, later in the video, if I mention that something is X times sweeter than sucrose, it is based on the minimum concentration needed for sweetness to be detected across an average group of human tasters, with sucrose as the standard of comparison, otherwise known as a sweetness rating of 1. Dextrose is 0.7 times sweet as sucrose. The first artificial sweetener that we'll be discussing is saccharin. It was discovered in 1879 by American chemist Constantin Fallberg on accident after he forgot to wash his hands after lab work before eating. It was approved by the FDA in 1958. Its usage increased during World War I due to sugar shortages, and now it goes under the brand name Sweet and Low in pink packets. The chemical name for saccharin is sodium 3-oxobenzeosulfonazole, with the chemical formula being C7H5O3NS. It is approximately 300 times sweeter than sucrose, and because some people detect a bitter/metallic aftertaste, it is often used to sweeten things that already have a naturally bitter taste, such as coffee and tea. Sweet and Low packets are noticeably sweeter than sugar, and the bitter aftertaste, although relatively slight, is certainly noticeable. The next sugar substitute is aspartame. It was discovered in 1965 by James Schlatter, and it was approved by the FDA in 1981. It goes by the brand name Equal or NutraSweet, and it is the primary sweetener in most diet sodas. Some people have a rare disorder called phenylketonuria, which prevents the metabolism of phenylalanine, so they shouldn't consume aspartame. Neotame is an aspartame derivative that was approved by the FDA in 2002 that is 8,000 times sweeter than sugar. However, it is very rarely used to this day. Aspartame is made of 2 amino acids, those being aspartic acid and phenylalanine, and it is also made of methanol. Its chemical name is aspartyl-phenylalanine 1-methyl ester, with its chemical formula being C13H18O5 N2. It is metabolized at the same 4 calories per gram as sucrose. However, it is 200 times sweeter than sucrose, so it can be used in much smaller amounts, so the same amount of sweetness comes for far less calories. Aspartame loses its sweetness when heated because it is denatured like a protein, as it is made up of amino acids, so it is not to be used in sugar-free baked goods. Blue Equal packets actually contain a blend of both aspartame and another sugar substitute, Aspartame potassium, which will be discussed later in the video. So this taste test will be for both. Equal packets have a much more similar sweetness to sugar than Sweet and Low. And if you ever had diet sodas, you can definitely tell that it's the same sweetener used in both. The third sugar substitute that will be discussed is sucralose. It was discovered in 1976 by British researchers working at Tate & Lyle plc. It was approved by the FDA in 1998, and it currently goes by the brand name Splenda. It is most similar in structure to sucrose, with the chemical formula C11H19O8Cl3, because it is produced by replacing 3 hydroxyl groups on sucrose with 3 chlorine atoms. It is 600 times sweeter than sucrose, but it is not metabolized at all in the body, so it is 0 calories. Sucralose is stable hot, so often it is used in sugar-free baked goods. Of the packets tasted so far, these yellow Splenda packets definitely have the fakest beginning taste, but much like the white sugar packets, they have essentially no aftertaste at all. The next artificial sweetener that will be discussed is Aspartame K, or Aspartame potassium. It was discovered in 1967 by scientists working at Hoist AG, and it was FDA approved in 2003. It can be found alone under the brand name Sunnit, or, as previously mentioned, mixed with aspartame in Blue Equal packets. Its chemical formula is potassium 6-methyl-1,2,3 oxythiazine 4,3H1,2,2 dioxide, with its chemical formula being C5H6O3NS. It is 150 times sweeter than sucrose, but it is not metabolized at all, so it is 0 calories. It has a slightly bitter aftertaste, like Saccharine, but it is high temperature stable, so it is also usable in sugar-free baked goods. Because it is also in the blue packets, refer to the aspartame taste test for thoughts that also include those of Aspartame K. The next sugar substitute discussed will be one from a natural source, that being from the leaves of the bush Stevia rebaudiana burtoni, which is native to Latin America and has been used by local indigenous peoples to sweeten things for centuries. It was approved by the FDA in December 2008 and goes by the brand names Truvia or Stevia. Stevia leaf extract contains 3 main compounds that all sweeten: steviol, stevioside, and rebaudioside A. It is about 250 times sweeter than sucrose. Stevia leaf extract comes in packets that are either green or green and white. Stevia leaf extract, very strong taste, and it tastes the least like sucrose, all tried so far. However, it doesn't really have that much of an aftertaste. The next sugar substitute to be discussed is the newest packet on the scene. It is the orange packet, which contains monk fruit or Lohangao fruit extract. It is the fruit of the Ceratia grosvenori vine, which is native to southern China and northern Thailand. The sweet compound from this fruit is triterpenoid mongroside glycosides, and it is approximately 300 times sweeter than sugar. However, it is not metabolized, so it has 0 calories. The orange packets originally taste like a much milder version of stevia and have a somewhat molassesy aftertaste. The rest of the sugar substitutes that will be discussed are all what are known as sugar alcohols, which can naturally occur in some fruits and vegetables. However, as none of them really come in packet form, they can't really be compared to table sugar, and so there won't be a taste test of it. The first sugar alcohol that will be discussed is sorbitol, and it is produced from glucose, and it is fermented by your gut bacteria or microflora to produce gas/intestinal problems if it is consumed in too large of quantities. Another sugar alcohol is erythritol. It is produced from the fermentation of glucose with the yeast of Monaliella pollinis. It is 0.7 times sweet as sugar, but is only 0.2 calories per gram. When consumed in large quantities, erythritol can have a laxative effect, and it was FDA approved in 1997. Xylitol is another sugar alcohol that was discovered in 1980 and approved in 1986. It is produced from a hydrogenation reaction of xylose. It is slowly absorbed in the human body, and it is just 2.4 calories per gram, so it is lower in calories than sucrose. It is safe for human consumption, but it is very dangerous for dogs. It has a very similar taste to table sugar. The final common sugar alcohol is isomalt. It is 0.5 times as sweet as sugar, and it is metabolized at 2 calories per gram. And isomalt will be found most commonly in sugar-free candy, as in candy making, isomalt acts in a very similar way to how sucrose acts during the candy making process, allowing sugar-free candies and sugar candies to be made essentially the exact same way. Sugar alcohols are commonly found in sugar-free gum and low-carb health bars and drinks, along with, as mentioned, sugar-free candy. And with sugar alcohols complete, this has been an overview of sugar and sugar substitutes.